Good morning, dear students. We are continuing with Module 5 and this is my third lecture. And in today's topic, we'll be continuing with the design of mode and counters. So, we have already seen one problem in the last lecture. Now we'll go to the second problem regarding mode and counter design. So we'll be designing here the mode 9 synchronous counter. So what is the meaning of mode 9? It can count 9 states from 0 to 8, 0, 0, 0, 0 to 1, 0, 0, 0. So the biggest count is 8. It requires 4 flip-flops. With 4 flip-flops, 2 raised to 4 or 16 total states can be found, but only 9 are utilized. So the states from 1001 to 1111 are invalid. So in the K maps, you have to put don't cares corresponding to invalid states. This is the state transition or the timing diagram or the state diagram. Sorry, it's actually the state diagram or the transition diagram. You start from 0, 0, 0, 0. So you go to 0, 0, 0, 1. Go like this until 8th state. Go back to 0, 0, 0, 0. This is how you have to draw the state diagram or the transition diagram. Now, the third step in any counter design is selecting the type of flip-flop and then constructing the counter's excitation table. Here we are going to choose T flip-flop. So what you need to do is first the excitation table of a single T flip-flop. So you know you should write the Qn plus 1 combinations. You know it is 0, 0, 0, 1, 0, 1, 1. Then write your T. So you should know this very thoroughly. That is, if your Qn plus 1 combination is 0, 0, your T is 0. If your Qn plus 1 combination is 0, 1, your T is 1, and so on, just by heart this table. Okay. Next step is constructing the counter's excitation table. So how can you construct a counter excitation table? What you need is, you need to write the present state, you need to write the next state, and you need to write the required excitations. So what is a present state? There are 4 flip-flops, 4 outputs, Q4, Q3, Q2, Q1. So in present state, it always starts from 0, 0, 0, 0. For mode 9 counter, it ends in 1, 0, 0, 0. You write all the counts systematically for the present state. So now you are done with present state. Next, you have to write the next state. How will you write the next state? Take each of the present state counts. Here the present state is 0, 0, 0, 0. What is the next count? It will be 0, 0, 0, 1. Now, what is the present state here? 0, 0, 0, 1. If your present state is 0, 0, 0, 1, your next state will be 0, 0, 1, 0. Similarly, you have to finish the next state. Now, once you have the present state and once you have the next state, you can write the required excitation. Using T flip-flop is always good. Why? Because in JK you have J and K inputs for each flip-flop. Here you have only a single input. So you just have 4 inputs corresponding to the 4 flip-flops, T4, T3, T2, T1. So how you can create T4? Take Q4 in present state, Q4 in next state. So this is Qn plus 1 combination. This is your Qn and this is your Qn plus 1. And then find T4. Example, look here. Here my Q4 is 0. Again, my Q4 here is 0. My T is 0. Look, another case. My Q4 is 1 here. And my Q4 is 0 here. My T is 1. So, similarly, you can fill all the others by taking Q3 in present state and Q3 in next state, you can form T3. Similarly, by taking Q2 in present state and Q2 in next state, you can form T2. Similarly, by taking Q1 in present state and Q1 in next state, you can form T1. So you can complete this table now. Now the next process is obtaining the minimal expressions for T1, T2, T3 and T4. So here everything is 0. Okay. All are zeros. And it's very good if you can put the zeros. Please don't skip this. In the textbooks they have not put 0 in some cases. But always do the K-map by filling all the cells. Okay. It's always good to fill all the cells because otherwise you may have doubt whether it is a 0 or a 1. That's why I'm telling please fill everything as zeros or ones. Now, when you form the K-map for T4, you will get an expression like this. You have two groupings. One is a quad and one is a pair. You can write it this way. I hope you know how to do the grouping. Here, look this pair. What is remaining constant? This. Q3 is remaining constant as a 1. Again, Q2, Q1 is remaining constant as 1, 1. That is why it is Q3, Q2, Q1. Now you can read this quad also. I hope you know how to fill the inside portion. You are going to take Q4, Q3, Q2 and Q1 and then fill the cells for T4. Look here. For example, I am taking this case 0, 1, 1, 1. What is my, which was that cell? T4, okay. So I am taking 0, 1, 1, 1. My T4 is 1. Look here. 0, 1, 1, 1. My T4 is 1. In this way, you have to fill everything for T4. Then you do the grouping and write the equation. Similarly, do it for T3, T2 and T1. Here, you need to form the K-map for everything because you are having, instead of all ones and x, you have zeros also. I told you, please always fill this. Even if the textbooks don't have the zeros, please fill that and group. Else you may find it confusing. Okay. Now you draw the final circuit. So here I need to draw 4 flip-flops T1, T2, T3, T4. Provide the external clock simultaneously. I have just drawn my preset and clear inputs as well. Then I draw the circuit. For example, what is my T2? T2 is Q1, T1 is Q4 complement. T2 is Q1. Look here. T2 is Q1 directly. Now, where is my Q4 complement? Look here. Q4 complement is taken directly and provided to T1. Look here. So this way you can complete the circuit. Now we'll go to the next problem. Problem number 3, design of a synchronous mode 10 counter, or mode 10 counters you call it BCD counters or decade counters. So question can come in any way. Design of mode 10 or BCD or decade counter. So mode 10 counter counts 10 states, 0 to 9, 0000 to 1001. The biggest count is 1001. It requires 4 flip-flops. With 4 flip-flops, you can have maximum of 2 raised to 4, 16 states. However, only 10 states are used. From 1010 to 1111, they are invalid. So you put don't cares corresponding to invalid states in the key map. This is your state diagram or the transition diagram. You have to draw from 0000 to 1001 like this. You have to draw like this. Next, selecting the type of flip-flop. Here you are using, I'm choosing JK flip-flop. I know my excitation table of JK flip-flop here. Now, I'm constructing the counter's excitation table. For excitation table, you need to write present states, then you go for next state and then the required excitation. In writing the present state, I start from 0000 and end at 91001. For each of the present state, you write the corresponding next state. For example, if it is 0010, it is 0011 next. So first you fill this present state, then you fill the next state, then the required excitation. By taking Q4 in present state and Q4 in next state, you can fill J4 and K4. Similarly, by taking Q3, it is like Qn plus 1 combination, you can write J3 and K3. Similarly for the others also. Now, you obtain the minimal expressions for J1, K1, J2, K2, J3, K3. Here you don't need to find for J1, K1 because see here, in J1, K1, nothing is 0. Look here, nothing is 0. So, you can directly write J1 is 1 and K1 is 1. So, for all others, you have to find the K-maps. So, I have found the K-maps for J2, it is Q4 complement into Q1. For K2, it is Q1. For J3, it is like this, and K3, it is like this. And now you draw the circuit. For example, look here. K4 is Q1. K4, you take it from Q1. Look here. Q1, you took it, directly connected to K4. Similarly, you draw you take all the equations and then draw the circuit. So, in today's lecture, we have mainly continued with the design of mode and counters. In the previous lecture, we have seen the design of mode 6 counter. And in today's lecture, we have seen the design of mode 9 and mode 10 counters. Mode 10 counter is also called decade counter or BCD counter. So please go through the lecture and let me know. Thank you.